The last of the three four helical bundled proteins we're going to be looking at was hemerythrin, looking like this. This is a small protein that has evolved to have functionality quite similar to hemo or myoglobin that we're going to be looking at later. So here we have evolved a binding site that can bind oxygen on the interior, not through a heme group or anything, but you have other ways of binding a few metals in a hydrophobic interior side here, and these two irons typically then in turn binds oxygen. They don't bind it as an O2 molecule as hemoglobin does, we'll talk about that later in the class, but rather binds this as an OOH minus group. So it's literally creating a bond to the oxygen. Just as hemo and myoglobin, this molecules exist in two shapes or forms. You can have a monomer of it, or in this case a tetramer or trimer, or occasionally tetramers. And they will have slightly different properties whether you're binding oxygen in blood or tissue such as muscles. You will not have these in your bodies. They typically occur in invertebrates, in particular marine invertebrates such as brachiopods. Exactly why is beyond the topic of this particular lecture at least, but you see the parallel here. Nature has evolved multiple ways to bind oxygens. This has different properties than hemo and myoglobin. Exactly what those properties are is irrelevant right now, but usually you tend to have simpler proteins in lower, simpler, smaller organisms, while higher organisms, vertebrates, have evolved more complex systems. There is a cost to those complex systems that we will come back to in evolution, so it's not always an advantage to have this nervous system. This particular protein is a four helical bundle, likely because those four helices essentially help us to create an interior. So if you look at these four pens, right, if you carefully select amino acids on the inside here to make the four helical bundle hydrophobic on the inside while hydrophilic on the outside, we're basically creating a pocket that can bind something that does not like water, such as the metal environment and everything in here, and the oxygen itself, which is a gas, is hydrophobic. And that means that the oxygen molecules will be able to diffuse here, bind, and then at some later point they should be released from the hemerythrin again. There is a reason why I'm showing hemerythrin to you. First, to show that it's this diversity in the four helical bundles, and second, this concept of carefully designing, or in nature's case, evolving the amino acids, is something that shows up over and over again in reuse or possibly design.